Hello, my name is Emmanuel Franco.
My name is Alma Llerenas.
My name is Juan Alonso.
And my name is Juan Pablo Rivera.
And we will be presenting rational functions. Our teacher is Pedro Bosco.
And we are group 11.
Okay, so our first step in order to graph this, which is something we're going to do later, we have to take in consideration that we cannot have 0 at the denominator. Now, why is this? Because 0 divided into any number is not defined in mathematics. So in order to do that, our domain will be all real numbers except those ones that gives us as a result 0 in the denominator. Okay, so the first question comes, what type of function is this one? And we decide that it is a rational function. Now let me explain you why is it that we chose rational functions. So the basic forms comes like this, where we assume that p of x and q of x are polynomials. Now the thing here is that p of x and q of x doesn't have common factors, which is something that we can perfectly see here. Even though we could factorize this one, there would be no sense if there is no factor in order to simplify, per se, with this the denominator of the pt function. Even though they both are polynomials, its graph looks quite different than a normal polynomial function. Therefore, our denominator, which is t plus 0.5, is going to be different than 0, which is something we got here. Then we transfer this into this equation. We isolate t, we get that t is going to be different than -1/2 because it's not defined for this function. Right? So we will assume that this is our vertical asymptote, the restriction we got here. Therefore, we have a vertical asymptote at x minus 1. Alright, so I want to show you the short procedure to get the horizontal asymptote. So what we're going to do, we're going to take the lead coefficients. In this case, it's t equals to t. And we're gonna do as follows, I'm sorry. Let's ignore this part. So it's gonna be like 200 t over t. We know that t over t equals to 1 and 200 over 1 equals to 100. Our conclusion will be that therefore we have the horizontal asymptote at y equals to 200.
So the next part of the project says, when was the population equal to 0? And we have to remember two things. Here we have again our function, and the problem says that t equals to 2. It means that we are in year 2002. So p of t is means the population. So if you want to know when the population was equal to 0, we have to substitute p of t for 0. So here we have it, and then we have to isolate t, because let's remember t means the year. Then we multiply t plus 1/2 here and here, both sides. And then we have 0 equal to 2000 t minus 120. And we have then minus 200 t equal to 120. We have t equal to 120 over 200. And the result is t equal to 3 over 5. This means that we are before 2001 because this is not equal to 1. So the next part says that we want to know the people that were in 2006, and we represented this with x. And let's remember again that when t is equal to 2, it means that we are in year 2002. So here we have our function again, and we substituted the t that represents the year for the 6. Here we have it. Then we have 2000 multiplied by 6 minus 120 over 6 plus 1/2. Then we have 1200 minus 120 over 13 over 2. We have 1080 over 13 over 2. And then we have 2160 over 13. And the answer of this part is x equal to 166.15. So now the problem is asking what was the population when we are in year 2020. So here we have our function again, as in the last part. We have to substitute t for 20. So here we have 200 multiplied by 20 minus 120 over 20 plus 1/2. That is the same of 0.5. And here we have 4,000 minus 120 over 41 over 2. Then we have 3,880 over 41 over 2. Here we have 7,760 and over 41, and the result is 189.26, and this is the population when we are in year 2020.
So as we see, we already have the vertical asymptote, the horizontal asymptote, the x-intercept, and the domain. We only need the y-intercept, the range, and the end behavior. So to get the y-intercept, we evaluate as t equals to 0. So we get this, and the y-intercept equals to we need to get the limit. So we evaluate as a limit of p of t as x approaches to minus 0.5 to the left. So this equals to So now we check the limit of p of t as x approaches minus 0.5 from the right, and we get minus infinity. If we check the limit of x approaches infinity, we get infinity over infinity. So we simplify the function, and we evaluate with infinity, and we get 200 as x approaches infinity, 200, and as x approaches minus infinity, also 200. So, with the information we got, the asymptotes, the x-intercept, the y-intercept, and the end behavior, the graph would look something like this. So now, with the graph, we can easily get the range, which is so we know the graph represents the population and how it increases over the years. So we know that in the point 0.6, the population is 0. So from this point to infinity, the population starts increasing. So we only take the values from this point, the values from this point to infinity. So the new restriction would be
To know if our function is increasing or decreasing, we need to know the limits that we have in here, and also the domain and the range. Okay, with this we can notice that it is increasing. It is going from with y0 to y infinity. Okay, but only according to the context of our population. We can only use the quadrant 1, and here we can notice that it is also increasing as it also approaches to y 200.
So according to the context of the problem, we only pay attention to the quadrant 1, and this limit applies, the end behavior. As x approaches infinity, y approaches 200. What conclusion can we get from this? That as many years pass, the population will increase more and more, but never reaching the 200. So we put the function in a graphing app, and as we see, it looks like the one we did.
In conclusion, realize that with rational functions, we can predict situations from the real life.